Today we're going to be adding and subtracting radicals. So your essential question is, when am I able to add or subtract radicals? And we're just going to go through a few examples, so this is going to be pretty short today. But the only time you can add and subtract radicals is when they have like radicals and like roots. So for example, for this one's ready to go. Because if you look, they both have 10 underneath the radical sign, and they both have a root of 4. So since they're both fourth roots, they both have the same number underneath, we can just add the coefficients together. Now remember, the coefficients are the numbers in front. So for this first one right here, the fourth root of 10, that would be like 1 times the fourth root of 10. So the coefficient is a 1. And then this one is 7 times the fourth root of 10. So what we can do is just add those together. So we will have 1 plus 7 and then the fourth root of 10. So if we simplify that, 1 plus 7 is 8 times the fourth root of 10. And that would be our final answer. So the only time we can add or subtract radicals is if they have the same number underneath the radical sign and the same root. Okay, for our next example, we have the cube root of 54 minus the cube root of 2. Now this is a problem because we have the same root, but we don't have the same number underneath the radical. So what we have to do is simplify this. Now, you might want to make a list so that you have it handy of your perfect squares or perfect cubes or perfect fourth powers or perfect fifth powers. That way you can break these down a little easier. So I'm just going to make a list over to the side here of our perfect cubes. So 1 to the third power is 1. 2 to the third power is 2. 3 to the third power is 27. 4 to the third power is 64. Now I'm going to stop there because we have 54, so I know it has to be less than 54, so I'm just going to stop there. I need to decide if there is a number on my list that divides into 54 evenly. So I always know I can use 1, but it has to be a number other than 1. So 54 divides by 2. And it divides, and I don't even know why I wrote 2 there. Having a hard time. So 2 to the third power is not 2, it is 8. Back to what I was saying. The cube root of 54, if I can divide any of these numbers by 54, I can break it down. Well, 54 divides by 27. So I'm going to break this down into the cube root of 27 times 2, because 27 times 2 equals 54. So I just split it apart, and then I'm going to leave this here because I cannot break down 2. So what is the cube root of 27? The cube root of 27 is 3, so I'm going to take that out. So then this turns into 3 times the cube root of 2 minus the cube root of 2. Well, now I have the same number under the radical and the same root. So I can subtract the coefficients. And remember, this one would technically have a coefficient of 1. So then I would do 3 minus 1 times the cube root of 2, which would be 3 minus 1 is 2 times the cube root of 2. So that would be my final answer. Now let's do one with some variables, make it a little bit more interesting. This one looks crazy. So we have cube roots, but this number underneath and this number underneath do not match. So we cannot do anything with them. Now we can go back up and we can use our same list of perfect cubes. And again, we have 2 and 54, so this is very similar to the last example. So I need to break these down so that I can take the cube roots. Now this one, if I look at this one, I can't break down the 2, but I could break down the z to the 5th power so that a cube could come out of it. So I'm going to break this one down. So 2 times, and then what number that's less than 5 is divisible by 3? So 3 is divisible by 3, so I want to break this down into the z to the 3rd power times z squared. because 3 plus 2 equals 5. So I have all of my z's accounted for. Okay, then I have on the second one, I can break down the 54. It divides by 27, so that would be 27 times 2. Okay, I use my list of perfect cubes. And then I can't break down the z squared because it's less than 3, so there's nothing I can do with that. So now I'm going to simplify. So I can't take the cube root of 2. What would be the cube root of z cubed? Well, if I take 3 divided by 3, I just get 1, so a z will come out. So now I have 12z, and then I have left over 2z squared. And then on the second example, the cube root of 27 is 3, and that's the only thing I can break down. So the 3 will come out. So now I have 3z times the cube root of 2z squared. And if you look, now we have both cube roots and we both have 2z squared underneath the radical. So we can subtract the coefficients. So 12 minus 3 would be 9z. 12z minus 3z is 9z. And then we have the cube root of 2z squared. And this would be our final answer. So you just have to break apart anything underneath the radical until they are the exact same. And make sure you have the same roots, and then you can add and subtract the coefficients of your radicals. Thank you. Make sure you go back and answer the essential question and write your summary.